Wouldn't be an amp repair shop without at least 1 or 2 Fender Blues Jrs a week. This one has come in because customer says we're getting some lightning in a bottle on the tubes there. Common enough fault, we've seen it enough times on these. Fender Blues Jrs and Hot Rod Deluxes and others in that family are sort of some of the amps we see the most of. Obviously not only because they're, one of the biggest selling amps of all time, but also because, to put it lightly, they still manufacture and design these amps using 1990s design thoughts and all the rest of that just don't make sense. There's a lot of silly design mistakes in these that could have easily been rectified multiple revisions ago, but they haven't. So, especially with the Blues Juniors, a couple of the common faults include the fact that they absolutely cook tubes when they run them with such a high plate voltage, but also really, really high dissipation, so well beyond their rated rating, it just eats through them. And then they go short and they take other things out, and sometimes they arc across on the boards. So you end up with really, really high consumable costs on there because they're running the tubes like it's 1964. Modern tubes aren't going to handle that. And even when you go through the actual data sheets of tubes from back then, they're just putting too much on them. Put them inside of a cabinet like this, a little teeny tiny semi-closed back cabinet, and the vibration from speakers, everything else is just torturing them. They're just going to die. Of course, one of the next things inside is all about the good old-fashioned caps inside there. These ship with IC caps. IC caps aren't bad. The caps Fender spec from IC for this amp and others are bad. IC is owned by CDE, Cornell Dubelier. Big, massive company. We're talking like billion-dollar industries. They're supplying caps and various other electronic components to everything from government to, mass manufacturing and all that. So you're not going to have a company that's around with something that's just an absolute turd of a product for very long. When you're a company like Fender and you're turning over, tens of thousands of amps a year, probably more, probably 6 figures of amps, if not more, a year. Every cent that you cut from the bill of materials is going to mean a big amount of profit. So the caps that they spec inside here are the cheapest ones that they possibly can. To someone like myself or an amp builder or someone else, an extra 10, 20 cents on a single component, that doesn't mean anything. That's, a few dollars onto the bill, easy. But when you're a company like Fender and you turn around to a company like IC and go, hey, we want 100,000 of these caps for this quarter alone. If you can cut 2 cents off of each single one of those, just on that quarter there, on one component, 2 cents, 100,000 caps, straight off the bat there, you've got $2,000 saved in 1 quarter on one product. There, that's it. Start adding up those figures across their entire product range, all the amps, all of that. Of course, 2 cents, they're still going to fight over it as much as they can, but it makes a difference to a company of this size. It also means that it's going to make a difference to you in the end when these caps spill their guts and you get awful noise, awful hum, and all the rest of that. First things first, we're going to flip this over, pull the back off, give a bit of a cursory inspection. We want to check the boards, want to see whether there's any of that bleeding there. Because the customer said there was arcing inside the tube, I want to check the tube sockets as well because they're prone to arcing over and having some damage. If they are damaged, we'll replace those boards. Easy enough to do, courtesy of a good friend of ours, Brad from Brad's Guitar Garage, who manufactures a replacement PCB that's much higher quality, through-hole plated, much heavier copper trace as well, and it's routed a bit nicer with some proper clearances and spark gaps between the pins as well on the output ribbon. Little things like that to him and I doesn't cost much to do, but to a company like Fender, there's big money. Let's get it in. Don't mind the tape on the back there, they're just covering up the customer details because I don't think he's going to quite appreciate if he gets random phone calls and emails at 3 in the morning from someone in the US asking how his amp's going. These, like the other Fender amps of its ilk, including the Hot Rod Deluxe, have the panel in the back here, and we've seen a couple of them where people have tried removing them and they've snapped across there. A little simple trick you can do to actually get that out a lot easier is, instead of trying to just wrench it out and get it out with your hands and force it out, there's 2 screws on the side here. Those 2 screws compress in the sides of the panels there, pinching on that, making it harder to remove. So if we just take a little bit of tension off of those there, that'll make removing it so much easier and less likely to cause this to snap. 1, 2, 3, 4, 5, 6. Oh, all right. Get those out of the way, put them in the magic magnetic bowl. Best trick I ever learnt from an old mechanic friend of mine. Except his versions were literally just sort of dog bowls that he'd epoxied magnets onto the bottom of it. It's a smart way of doing it. I was lucky enough to find these in Kmart. So Kmart actually sold them as a set, and I grabbed a couple of them because they're well worth having on hand. All these little ferrous screws saves them having to fly around and end up all over the floor and that. And if I do drop something on the carpet, I can actually just pick it up and whoop, float it around like that, because that side's the magnet there. That's helped me find screws on more than one occasion. And just by taking off the tension on the sides there, just makes it so much easier to remove that panel. All right, now we've got the panel off, and we start doing some inspectionating. Let's get this cover off here. I know some techs out there absolutely hate this cover. It doesn't bother me that much. Other designs I much would have preferred, but such is life. Now, inspecting these tubes, out we come. Come on. So, not looking the worst for wear, but looks can be deceiving. So we're checking the outside there, see if there's any sort of burn marks or anything on there, which isn't, which is good. A little bit of discoloration on the logo here though, so a bit of heat going on there. Pull that one out as well. Come on. This one's got a little bit more heat as well on that side. Once again, looking pretty clear, so not too bad all in all. So I'm not seeing any physical damage, which is good, but when we plug it in, we test it, it may very well arc up. I just want to double check to see whether that is going to indeed be the case. With these and the Hot Rod series, there's a couple of sort of quality of life upgrades that can be done to these just to make them more reliable, less problematic. The first things first is always going to be replacing the caps, because it's not a case of if they're going to fail, it's going to be when. Putting a better quality set of caps in there, or some higher rated value, higher rated thermally caps. So putting a good set of 105C rated caps will typically mean you're going to end up with something that's going to last a bit longer. There we go. That tube's still all right. And this one here. Oh, come on. How's that looking? Yep, made in Russia, 2020. So this one's pretty darn new. I'm going to check on the date codes and all the rest of that, find out exactly how old it is. Here we are in the guts of the amp. Taking a bit of a look here. And I'm not seeing anything leaking out of those caps yet, which is good. Given the age of them, I probably wouldn't expect it, but you never know what's really going to happen. Board otherwise is looking pretty okay. Oh, let's take a look down here. That's PCB there. So I'm not seeing any shorting or any arcing, no carbonization. Ew. There's something in there though, something that looks a little bit weird. Grab my tweezers. Come here. No, I want the round nose ones. Thank you. Don't know what that is. Is it a dead bug or is it just a piece of fluff? What is that? Ugh, of course it is. Of course. Right. Cool. Well done, Fender. Well done. That one too. Yep. Gonna say, why would we just? Yep, getting a bit stun locked here. What I actually did was I removed something from the board that I thought maybe it was a bit of fluff or a dead bug or something like that. But this actually seems to be a bit of a common problem that's happening with some of the newer Fenders. The rear of the amp looks like this. So it's just a piece of aluminum shield that's adhered onto the back there. It comes as a big roll, you put it across, you cut it, it's adhesive on the back. They're putting it on, but instead of pre-cutting or drilling the holes there for where the screws are going to go through, they're literally just punching the screws through. And bear in mind, we're talking machine screws here, and just leaving foil floating around. That's incredibly conductive stuff. And I just found, 1, 2, 3 lovely bits inside the chassis. And this little one here was in a wonderful spot. Throwing the pointing stick around, I'm so annoyed. It was actually here in what would be, yep. So those are the flyback diodes there for the output. So I was bridging between the flyback diode there and is that the 1.5, yep, 1.5K, so that's a grid stopper there. That just, seriously, I mean, it would take an extra couple of seconds to not do that, to just cut it away or punch it or do something so there's not flecks of foil floating around in the amp that can short out. So if we've gotten something that's gone from the flyback diode there, which is connected to the high tension B+, that thing, high voltage, and the grid, that may explain why there was flash over in the tube. Could have also meant that they've ended up going red plating, but I can't see anything there, but it may have just been short enough to do it. Wasn't any fuses that had been blown, so it was still operating. And just, it's so incredibly frustrating. Just for pertinence sake, I'm going to power this up, just keep an eye on those tubes and see whether they're going to go bang or make any bad noise or do anything like that. I'm just going to feed it up slowly first on the variac, keep an eye on the current, and then we'll sort of keep an eye to see whether we end up with any bad noise or arcing or anything like that coming from there. On to the next step. Now let's see what happens when we power this jobber up. I'll sort of keep an eye on it and make sure we're not getting excess current draw or anything sort of weird going on. Keep an eye on those plate voltages and voltage at the first node as well. Yep, so that's going to pull a fair amount of current there just to get the variac energized. There we go. So we're already at like 50 volts on the variac and getting about 81 through the first node there. Yeah, it's good. All right, so I'm not seeing anything that's immediately saying that there's a short or anything, which is good. We should hopefully start seeing those filaments warming up in a moment. Or not. Yeah, they are looking a little cold. Oh wait, no, there we go. It's just a really, really bad angle. Oh yeah, there we go. Oh yeah, there we go. Whew. So that was yeah. So So that is something that does happen from time to time. No matter how many times you do that, it still freaks you out. Right, they're going, bye-bye. That's relatively simple, but I also want to have a chat to the customer, see what he wants to do, because there's a couple of quality of life upgrades we can do to this to make for a better amp all in all. First of all, we can get those caps out, replace them with some shiny new ones, but also the screen grid resistors on these EL84s. If I remember correctly, which I usually do, let me just double check this schematic. 100 ohm burners. So they are going to just be way, way, way too much. If we bump up the value of those there, that's going to provide for some longer life to the tubes there. Another thing we can do as well is tame the bias a bit so it's not pushing it up quite so hard. Can't really do much to actually deal with the the plate voltage. That's down to the transformer. That is what it is. But if we can at least deal with the plate dissipation a bit, bring it down to a bit more of a reasonable sort of level, balance it between plate dissipation and the voltage on the plate, then we can at least get a bit more life out of them, make them a bit more robust, a bit more rugged. With anything to do with biasing on an amp like this, when you change the bias, you're also going to change what you're going to get on the plates as well. So that's kind of where the trade-off is. If we change the bias too much and drop it down, then we're going to increase the plate voltage too, which can increase the risk of shorts and dying and all that. And basically what happened there with that one. So I'm going to give a call to the customer. I'm going to see what he has to say. And then we'll start progressing on to the next step.